So you can see here that is the quantizing effect that go through to the y-axis point of view, cuts through to the y-axis. Now that's the graph of a signal. So for this graph, these points are the samples, and for this point, the topmost point from the graph, from the curve, is the effect of quantizing. Here you can see that there are some process of quantization. As you can see, that is quantization error, that is another term. In rounding is limited to the range. Delta, that means minus delta by 2 to delta by 2, should have to be the range. So delta is the quantization step. L x max minus x minimum divided by L minus 1. L is the level of the binary data. In the in the coding process, the analog to digital conversion assigns a unique binary number to each quantized level. That is the coding process. Each quantized level, the ADC assigns a unique boundary number. As you can see, there are the unique binary number for that occasion. 2 to the power b is greater than or equal L. L is the number of quantization levels. B is the number of bits, that how many bits we have to use to communicate through wireless channels. And after that it has been expressed to that kind of equation by taking the logarithm in both sides. Then calculating, we get the b into fs. B means the number of bits, fs means the sampling frequency, is less than or equal bit rate. So number of quantization levels is known as L. So if we consider the signal like that, that is considerably discrete signal, discrete time signal, as you can see. So there has been the quantized step has been given, that is 0.1. That means the n should have to be increased by 0.1, 0.2, and so on. And that is the signal, that is the discrete time signal. And after putting the value, we get the value from there. There is the first 10 samples value we get, and that is the final of result of this problem. Okay, this is the final result. So consider the analog signal xt is equal to 3 sin 100 pi t. So first of all, we have to sketch it through 30 millisecond parameter. 3 millisecond is the step size. Then after calculating up to 3 decimal places, the signal xt sampled at 300 samples per second, determine the normalized frequency of the discrete time signal and what value of it t is xt at its maximum minimum. Okay, after opening the university, I will give you the lecture on the problems, that how to solve the problem in these. So from that point of view, it's enough, and that's all to just understand the analog digital conversion. Okay, thank you very much for being with me.